What limits resolution for Earth observation satellites? Imagine trying to read a tiny sign from thousands of miles above the ground. That's what satellite resolution is all about, how clear and detailed the images can get. But many factors make this a tricky goal to reach. First, the size of the satellite's optical system plays a big role. Larger lenses or mirrors can focus more light and produce sharper images. But bigger optics mean a bigger, more expensive satellite that's harder to launch and operate. The satellite's altitude also matters. Satellites in low Earth orbit, which are closer to the ground, can see more detail because they are nearer, but they can only cover small areas at a time. Higher orbit satellites cover larger areas but with less detail. There's a constant balancing act between different types of resolution. Spatial resolution is about how small an object can be and still be seen clearly. Spectral resolution relates to how many different colors or wavelengths the sensor can detect. Radiometric resolution measures how well the sensor can tell differences in brightness. And temporal resolution is how often the satellite revisits the same spot. Improving one often means compromising another. For example, making the sensor more detailed might reduce how often the satellite can revisit a location because it covers less ground per pass. Signal-to-noise ratio is another challenge. When sensors try to capture very fine details, they collect less light per pixel, which can make the image noisy or grainy. This noise makes it harder to see small features clearly. Data volume is also a big factor. High-resolution images produce huge amounts of data that the satellite must store and send back to Earth. Limited onboard storage and bandwidth means satellites can't always send the highest resolution images instantly. Viewing angles also affect resolution. When satellites look at Earth from angles away from directly overhead, images can become distorted or blurry. Atmospheric effects add to this problem. The atmosphere can scatter and blur light, especially in optical sensors, reducing the effective clarity of images. All these factors combined mean that satellite designers have to find the right mix of optics, orbit, and sensor capabilities to meet specific mission goals. Whether it's detailed urban mapping or broad environmental monitoring, understanding these limits helps in choosing the best satellite for the job.